I think we're live. Twitch hasn't updated yet. We'll see it in a second. Yeah, there we go. Okay, we are on. And I can hear somebody's audio.
Yeah, I forgot to mute the Twitch stream.
So we'll give it a second. Let people tune in.
I do already see Marcus in chat, so
Yeah, need some intro music.
He's a
Well,
faithful follower.
you just missed Peter singing some final countdown music, so that was pretty wonderful pre-stream. So yeah, how's everybody doing? I love that it still says 0 viewers, but we've got a bazillion people in chat. So yeah, welcome to the version 2.0 release party. Can I make the names bigger? No, I can't. It's just Google Meet. And we are live with several of the developers of Binary Ninja. I think this is the first time I've ever had people actually guests on my stream. So say hi to Peter, Rusty, Tim, and Jordan. And I think we're gonna take it from there and push the button.
and by button we mean several buttons. So Rusty's pushing the actual button, which involves, so there's a lot of pieces, right? I'll kind of give like an overview of what's happening behind the scenes, and then we actually have two other of our vectorites that are going to be updating the website, the backend server, the database pricing, the purchasing, the PO system, the frequently asked questions documents. So several of these things are all going to get kicked off.
So what you're saying is there's potentially a race condition here where they could get 2.0 for the cheaper price. Like I believe
the purchase is going to be disabled. But if you happen to override the disable button, I'm not saying it either. One of two things will happen. Either they'll get it at the old price, or we'll just get money and they won't get a license. One of the two. So I'm not sure which.
If you're willing to give us money and no license, then risk it. Go ahead.
We will happily give everyone a license manually that gets in that boat. But yeah. So and actually, this is like the chain of events that happens is we have like an internal release candidate channel. So like you have the update channel, the dev channel that most of our users on. We have like an internal channel that is the like next stable waiting to happen, and that's so we can test all the update infrastructure even before we're pushing something live. And so the update infrastructure allows you to kind of merge from the release candidate just to the public one, and it just kind of changes some symlinks essentially. Like it doesn't actually move any files around, so all the files are already on the update infrastructure. It just makes them available, and so it also makes like the fancy changelog stuff too. That's a part of it. And then once that's done, then our Josh, the other Josh, is going to hit another button, which is going to pull the changelog down from the update infrastructure, and that's what actually populates the website, and like the hashes get updated as well. Update the installers, and then, like I said, do all the other stuff that I described. So yeah, there's a whole bunch of things. We actually had like a whole dry run yesterday where we like scripted through all this, because usually we kind of do this like over like, okay, it's time, and we can start to like do it.
It is live on the update server.
All right. Go.
Oh, I'm gonna go.
Wait,
I'm on dev channel, so it doesn't even.
Yeah, you've already basically got it. There is actually like one fix I think that's only on master right now. It's not actually on dev because the dev release didn't go out, right? So
no, the dev release did go out. Jenkins decided it was going to do the dev build anyway.
Thanks to whoever just followed. I got the little alerts hidden behind the Google Meet one, I think, so you can't see it. Anyways, yeah. So let's do the demo and see what's going on.
Let's so I don't even know if everyone on stream like knows who we are.
Oh
so
yeah,
should
maybe
we
y'all should intro yourselves.
Do some intros? Since I'm already talking, I might as well go ahead. So, my name's Peter LaFosse. I'm one of the 3 founding members of Vector 35. I what do I do at Vector 35? Basically everything, from finance to managing the Binary Ninja project to proposals and stuff like that. And just kind of everything, as well as lots of coding. On a good days, it's lots of coding. On bad days, it's like
it's lots of Excel spreadsheets.
Which
Somebody's gotta do 'em.
I kind of have a sick fetish with Excel spreadsheets, but we'll leave that aside.
What is your favorite feature you personally wrote for Binary Ninja?
Oh, that's a good question. I'm gonna have to say the plugin manager, because it's kind of like, it's pretty, like, no other reversing tool really has that, like, built in, and you can have these user submitted things and just like one click and install. I think it's pretty unique, and
it's a really
great feature.
I use it all the time.
Yeah.
All right, who's next? Jordan?
Well, yeah,
I'll go.
Diagonal.
I have no idea what layout we're in, so yeah. I'm Jordan. People know me because I usually just talk a lot, so a lot of people know who I am. I'm like the loudmouth of the company online.
Yeah, Jordan, you own the company, right?
That's what a lot of people think. So Rusty
CEO.
and Peter and I am technically something like that, just because we had to fill out
On
the paperwork.
paper, certainly.
Like literally,
President, I think.
It's something. I don't know. But Peter and Rusty and I are the three co-owners, so we're all kind of even owners. Peter and I do more like the day-to-day administrative stuff. So as Peter was saying, like the finance, the like all the kind of logistic stuff. Like he and I share that burden, which is nice because like neither one of us has to totally do it all, and then the other one gets to have all the fun of coding. So we both get to do both, which works out really well. But I do. I did more than the infrastructure, so like the sales, support, purchase, like update, kind of all that stuff. I don't touch the core a whole lot. I mostly do more Python stuff, and so I've got a lot more code like the Python
And
API.
docs.
And docs, yeah, that's my other thing. Like I try to do the stuff that nobody wants to do, but makes the product better. So do all of that. My favorite thing I've done is probably snippets.
I knew that was coming.
The snippet editor was so that was when Rusty first implemented like the pluggable UI, like it really made the UI extensible, and UI plugins were a thing. And so we had like a 1-week hackathon, and that was my prototype, was a snippet editor. And I was like, oh, this is a cool thing, it'll be fun. And like I continue to work on it since then. And I've got a lot of like sample.
That's the most significant portion of code too that you've committed to.
It is like, especially like one big like thing that I wrote all of essentially. Yeah, like
Well,
I usually just do a little stuff here and there.
Super useful too, because it's way easier to prototype something real quick. You can assign keystrokes to it. I actually used it, I know, in my emulator that I wrote on stream. Instead of actually building out this whole like callback system and things for being able to hook instructions in the emulator, I was just like, well, I'll just use the snippets, and I could call the snippets from within the emulator.
Oh yeah, to the active system,
and it gave me nice little callbacks that you could just register with the names. It could find them in the plugin, in the command palette with them. It was awesome.
Yeah, and it is funny too, because like I think like Peter mentioned the plugin manager, like it's not the most technical problem we solved. It's not the most interesting, like low level, but like the things that make the product more usable often aren't, I feel like, in a lot of ways. Some of them are, like, if Rusty goes next, he can probably touch on some of those, but yeah. So with that up, like Rusty, why don't you go ahead and go next?
So I'm Rusty. I'm the main architect of Binary Ninja. I've developed all the ILs that we have. I developed a lot of the initial code. It actually is a project that started a long time ago. If you've looked at our GitHub, you might have noticed something called like the deprecated Python Binary Ninja thing. And that's where it started. It started as a big Python script using the old PySide. And we thought it was pretty cool and decided to make an actual product out of it. And Obviously, that version is not anywhere near as sophisticated. It doesn't even have a function list. You can't really navigate around the binary very well.
But
So
it
we
does
thought
have
we
one feature we still have yet to add
Well, two.
to
It had
Binary
two.
Ninja, the
It had two.
emulator.
It had the emulator and it had the shell. It had a built-in like shell.
Oh, right.
And the truth is we actually need that terminal because a bunch of people come in and will be like, I can't get iTurn or IPython or Pwn tools or something that needs a PTY to be able to work.
Mhm.
And being able to have an integrated terminal would actually be kind of useful.
Yeah, debugger could use it too. Now that debugger,
the debugger could also very much use it.
We've got
There's open source
for
things out there now.
Can we get the canon pronunciation of BNIL from Rusty?
Oh, that's a good question.
I don't really ever say it because I'm pretty much always mentioning a specific IL.
So for me, I'm the one that invented the term. It's BNIL.
There we go.
Not bean ill, as some people say.
It's pronounced
It's
Jeremy.
BNIL. So it actually happened that, we were just talking about, it's going to be IL, and we were talking about, and then we were actually preparing for our first talk about it at
Was it
Infiltrate?
Yeah.
And I was like, hey, guys, we need a description for our family of intermediate languages. How about Binary Ninja Intermediate Language, which is the all-encompassing. We also say MLIL, LLIL. We don't try to go L-lil or M-lil. Some people do. I'm not going to make fun of people that do, but, it's just how we pronounce it.
So obviously, I did write high-level IL, and I do like that feature. But I think my favorite feature going above all else, and the one I use all the time that I did actually write, is the command palette.
I was going to say that too. Yeah. Yes.
That command palette is pretty great.
I love the command palette. Use that all the time. Especially, so I think my favorite part of the command palette is something I think maybe Brian added. That is being able to restart Binary Ninja from the command palette.
Yeah.
I use that.
Be able to
all the
restart
time.
with the options that you started it with, even, which is really nice.
So if you specify the command line and then restart it, you get that's
so if you have the file open, right?
Yeah, one of the main things I do is just Command P res enter, Command P res enter, and that's I do it. I
actually mapped it to a hotkey. That's how common it's Command Control Option R is my restart binge. I don't want to accidentally do it, but
you want So with Zombies is saying we should be doing a demo of these features. I could probably pull something up if somebody wanted to. Yeah, let me. Okay, so somebody else asked pretend they don't know. So let me see if I have something I can bring up real quick. Let me clear my recently opened. And
they didn't get an intro for Tim.
Oh yeah, let's do Tim, and then we'll talk about it.
Man, I was hoping I would get out of that. That's okay. I have a slightly less storied history, more of a newcomer, but I've been, I think, invited to participate to show some of the things that Binary Ninja will have in the future, which we'll do towards the end of this. So, I won't steal the thunder from myself for later on.
Yeah, but you have been before Binary Ninja, you've done reverse engineering. You've done development of tools for reverse engineering. You had CGC.
Right. Yep. So I've developed program analysis tools for many years, and I headed up the Deep Red team that participated in the Summer Grand Challenge. Yep. So I've been doing it for quite a while.
Awesome. And I
Yeah,
guess
and God.
oh,
Somebody did ask a question on the chat though about dwarf support, and so I might have something to say about that as well.
nice.
Later on the call.
Yeah. And for those that don't know, I am Josh. This is my Twitch stream. I have not been streaming very regularly lately because of the whole shelter in place thing, and I have kids at home, and I have to actually like take care of them and make sure they don't kill themselves. So my days are a little weird. So I haven't streamed much lately. But when I'm doing my regular schedule, you can find me building random tools and doing program analysis stuff using Binary Ninja. I literally just F around with Binary Ninja for a couple of hours on stream. Things I've done in the past.
And you also have a training too.
Yes,
Make sure you mention your
and
trainings.
I do trainings, which I'm not doing right now because I'm stuck at my house.
Yeah, and we will say Josh knows more about Binary Ninja than probably any non-Vector 35 employee, and probably more about how Binary Ninja actually works than most Vector 35 employees.
Yeah. I'm always really excited if I ever know something Josh doesn't know in the Slack, because it's rare.
Because
it's very rare.
Because I mean, we're developing the software every day, but he's like using everything we produce like every day. As he's like, we're like, oh yeah, we added that feature a while ago. He's like, yeah, you did, but it's broken.
Well,
Like,
to be fair, like, a lot of us are deep down in C++ land and doing stuff in the core, and
Right.
we don't really consume the Python API as much as most plugin authors would.
Mm-hmm.
Yeah.
I will say I have had to reverse engineer parts of the core before in order to figure out how certain things work.
You shouldn't have to do that. You should just ask.
We have shared code before too.
Well, yeah, but
code,
sometimes
we've strongly considered giving you GitHub access to the source code.
I would love it.
That would be easier.
So it's sometimes part of the challenge of figuring it out for myself is fun. So
turns out reverse engineers like to reverse engineer.
It's true. So on my stream before, I've done stuff with like deobfuscation. I wrote an emulator.
You wrote a decompiler.
I wrote a decompiler before, which was pretty cool, but much slower and not as good as high level IL. So don't use mine.
I mean, what can you expect out of Python? Python is not the fastest language I've ever seen.
Neither is C3, which
one of my tools that I have started to write when I'm on stream, but I haven't finished yet, is a refactor of a plugin I wrote a while back for Objective-C visualization, which I think is one of my favorites. And I'm rewriting it in C++, and so it's a lot faster now. I would probably say my favorite was the deobfuscation stuff, because it was just so fun to watch the code that made absolutely no sense and was just like a bunch of push rets and things like that patch itself automatically and watch the control flow grow and then change basically as an animation until you ended up with this like very clean code that actually did what it was supposed to.
That and trolling people on the internet.
Yes, I definitely... The deobfuscation stuff was definitely written completely out of spite, just to break the guy's stuff after an argument on Twitter. So
spite was we because of that we put spite on like YDURE, like on our like community yearly survey. We actually have like a for work, for malware, like spite was on that list.
It's a very powerful motivation. I will say. I worked long and hard on that.
I don't know if you saw the guy who was talking about getting banned from Call of Duty because he had it open in IDA. He's like, well, I'm going after your anti-cheat system now.
Yeah.
That was spite.
Exactly.
Yeah. I wasn't going to hack you before, but now.
So, before we get into the demo and stuff, do we want to talk about any of the other features, or do we want to just go straight into high level IL? Because some people in chat were asking for
What do you guys want to see in chat?
examples. Yeah.
We got one question that went by. Josh just mentioned that he wanted to know who did the basic block layout for the CFG view, and that was Rusty.
I did.
Yep.
And there are definitely ideas for definite improvements in it, but we have not had the time to do them yet.
Yeah, it's
But
like one
I'll
of
read the
those
second-
things that we'd
I'll read the
always
second half
want.
of the question though. Hold on, the second half says, "I almost always prefer it to other tools." So usually we're used to hearing complaints about it, but he actually likes. There are things we see all the glaring faults though. So
Right.
Yeah,
Like-
we're seeing like the random edges that go through the block, and like we really need to fix that.
Yeah.
All right, so yeah, people are asking. Let's see some Binja. So I'll pull up something real quick. What do y'all want to see? So I have a. This is just calculator that I pulled up. Let me switch to my other thing in OBS, so it looks a little clearer. So let's see. The command palette is nice. You can just hit Command P. And it brings up this thing. If you've used Visual Studio, it's pretty close to the Visual Studio Code one. Like works the same way. You can just start typing stuff. This is my favorite one, Restart Binary Ninja. And if I do that, it will literally just restart Binary Ninja.
I like Peter added the hotkeys on the side, so that's a nice way to like learn
Yes.
hotkeys too. Like if there's already a default key binding, I think that's a really nice touch too.
Yeah, and we actually have well, Brian and I have a plan for making this even more like Visual Studio Code is, how you can change settings from within this view.
Oh, really?
So like you can when a setting, like you can search for a setting in that view, and then when you hit enter, it will, like if it's a drop down list, it'll just give you the list of options, or whatever. And the setting system is super flexible. Brian did an awesome job at that. And it like there's APIs for doing all that setting that would make that pretty straightforward to do.
Yeah. So yeah, I can run, say like my Objective-C plugin that I've been rewriting, and you can see it automatically filled in all of the functions from Objective-C stuff. There's a lot of stuff I still need to do on it, but
Nice.
it's super fast now. Yeah. So thanks. I see Brian in chat. Thank you for adding the command palette and the restart stuff. So let's see. If Rusty, do you want to take it away and show you got a demo for high level IL?
So instead of just showing a bunch of high level IL, I'd actually like to show some of the internal ideas we're doing. Just making sure this actually shows up.
Yeah, I see it.
Okay.
Yeah, we see it. We see it.
So I'm just going to load up this simple binary. As you can see, high level IL is very readable. You get very C-like constructs, can very easily see what's going on. You've got your for loops here, very, very readable, as you would expect from a compiler.
I see almost no go-tos when you're doing stuff.
So there are,
which is...
well, this one's funny because I wrote a go-to into this code, and the decompiler figured out how to do it without a go-to, and it was more readable than the original code, which was that was a fun one. This one, it did have to use one because, well, the original code had a go-to in it, so it's fair that it actually did use one.
So my initial guess when you were writing this was that you were going to do the no more go-tos style of decompilation.
Yeah,
Did you change it up a little bit to
Oh,
do
yeah,
go-tos?
there are significant differences. For example, our goal is not to have no more go-tos. Because in a lot of cases, it's actually clearer if you use a go-to.
Yeah.
Because a lot of times the original code had it in it.
Mm-hmm.
A good example of that is error handling.
Mm.
If you see the old joke, go to fail. That
Yes.
style, if you do it with conditionals, it gets really ugly really fast because you get these chain conditionals that look awful.
And you have to duplicate code everywhere.
Yeah, that was a problem I
Kind of
had
figure
with
out,
my decompiler.
is this condition just way too hairy and it'll actually fall back to a go-to. It doesn't always do the best, like as any decompiler it's not always the best output you could ever get, and we're going to be continuously trying to improve it.
Yeah, that's my favorite thing. Like this is sort of like the 1.0 of the decompiler, right? So this is our sort of first out of the gate minimum standard, and we're really, really happy with it. We just wanted to like have, we knew we were going to solve everything, but we just wanted to do a good enough job that like everyone's like, yeah, 100%, that is a good decompiler, it's quality. And now from here we can add all sorts of stuff to it.
So the decompiler is interesting because plugin authors are going to be wanting to work with this. And it's not just a CAST that we have. There's also this graph form that you can see here. You can see it's a little different because you don't see the for loop anymore. The reason behind that is if you have a for loop in a graph, you have edges coming into it. Which one does it run? Does it run the init expression or does it run the condition? So you can't really figure that out from a graph, so it actually is different in the graph form. And I'm going to open up the Python console here and start looking at, so you notice there's instruction indices here, 1, 2, so you can actually access those instructions like you could in the lower level ILs. And you can see it's an HLAL while expression. But if you want to get the AST of it, you can actually move between them. So here I can do .ast, and if I print that, you get the for loop as it existed in the AST. So you can move back and forth. If you want to just traverse the AST, you can do .root, and that gives you, and you can start traversing through all the statements in an AST form of it. So you
That's
can
probably
actually
my favorite thing about high level IL is that it still follows the same format as lower level ILs, like medium level IL. And so when I was playing with high level IL on dev on my stream a while back, I was able to very easily write like a visitor class to just traverse these blocks and the for loops and things like that, and it worked exactly like everything else I've ever written for the IL. It just jumped right in and it worked.
So if we brought up the no more go-tos thing earlier, and how did we design this? So if you run this command here, current function .request debug report high level IL, this actually gives us an internal debug report. Anybody can do this. This is shipped. It's there because we've already had users submit bug reports that use this to say what exactly went wrong in the decompiler. Because this shows you everything that the decompiler did to try to disassemble this function.
And this is especially helpful when there's like a user who's got a sensitive binary they can't share, and they're like, well, your decompiler is wrong, but I can't give you my binary. And like, well, like how can you describe for us the problem? But with this, they can go into just the conditions, just the very, and take a couple of screenshots between this transition and this transition. And yeah, it's much, much easier for us to fix things without having access to binaries.
So this initial state here is basically a direct translation of the medium level IL into the high level IL instruction set. So it's a 1-to-1, but translated the instruction set only. Then we convert it into SSA form, which is very useful for analyzing the variables here. Then we start optimizing this IL. So we eliminate the unused fee functions. We have this copy here. See this? This is just a copy of a variable that's not needed. It just eliminates it and folds it in.
Love that
You have
feature.
eliminate unused pure call. So this dunk up here is a function that just returns its own return address. And we actually have the idea of a pure function now. And it knows it returned not a constant, but a known value in this case. And it did not use the result. It's just used as the constant folding is already taken care of it. It knows that. So there's no actual uses of this. So it just eliminates the pure call. Because by definition, pure function has no side effects. So you can just get rid of it.
I had a friend complain to me. He's like, I was using a high-level IL. I really like it, but man, it's got some bugs. I'm like, oh no, like what are you talking about? He's like, look, I've got the disassembly, and there's this Sterling call that gets just disappeared entirely from the disassembly. And I was like, well, let's look through it. We're going, and all of a sudden, I brought it back to the folks, and Peter's like, yeah, if it's a pure call, there's no side effects. That's the right thing to do. And I even said when I looked, I'm like, well, the output's not being used, but I don't know if we don't actually have interprocedural analysis. It's like, well, no, but you do have. Peter's like, well, we do have pure calls, and Rusty built that as a part of it. So things that you wouldn't think it would optimize away because normally interprocedural data flow is just super expensive, and you can't do that kind of stuff. But it's super nice.
So then the next step is to actually get it out of SSA form, because when doing the control flow analysis, you don't want to be constantly having to update all the phi functions and everything to make them correct. So it's actually cheaper to do it outside of SSA form, because now we're going to go into the control flow analysis phase of things. So the first thing it sees is this loop here. So we have this loop here and then an exit to the loop. And we lift out the body of the loop. And then we start looking at the parts of this loop that we can just fold down. So this is the highlighted 3 nodes here is a region it saw that was just a basic single entry, single exit kind of thing. So it creates a graph of the conditionals and then starts merging them to try to simplify it. So it merges 2 equal conditions. It sees that they're the opposite of each other, so it's just an if else. And then it creates an AST of it.
So one thing I want to interject right here is all of this stuff, this report is amazing. And you can actually make reports like this yourself in Binary Ninja using the API. This is nothing special to the core that is not exposed. I've actually made reports after I first saw Rusty's reports that he was making for high-level IL. I actually incorporated that into my decompiler that I was writing and did something very similar to this, just using the API.
Yeah, I don't think I've actually seen any public plugins make use of report collections like this yet. But yeah.
Yeah. And for what it's worth, because some people are talking about it in the chat, we actually will not. Sterling isn't considered a pure function because it reads from memory. One of the things about pure functions is that they specifically don't read from memory, because memory can change, and so that would make it. The definition of a pure function is it's always going to return the same thing given the same input, and because
in that case, memory is a whole as an input,
right?
So you can't
say that.
You can't optimize it out.
Is that true? Even if the memory is a constant value,
that is a special case of it
anyway.
But we're also not going to do loop summarization to be able to figure out what the output of a loop is, unless we wanted to integrate Z3 and run forever.
We do want to integrate Z3 at some point.
We
just solve the halting really problem. Cool what's the problem here?
Yeah, special cases.
It'd be nice to have it built in.
So yeah, we're just going to continue. This is basically the same stuff. Then eventually we get down to replace loop body. So all that the loop that we figured out is now replaced in the original graph. And then it recognizes that we have this while true, and then immediately if this expression break. So it actually knows how to transform that and just fold that break into the while statement itself. And then we just continue on with the same kind of stuff, just to fold these nodes into one. So now we have one node. So we're basically done, and then it does some post-processing to try to figure out for loops. So it looks at all the while loops, looks for these variables that it's checking immediately after or immediately on entry and immediately before the entry, and just folds them into a for loop. And that's how you get your for loops.
And I'll point out too that it's one thing that surprisingly Ghidorah doesn't do is the for loop recovery.
And another interesting case would, of course, be how do we deal with switch statements? It's always an interesting problem to discover. So here you can see
very large step one.
In our medium level IL, we have all these like jump table calculations, and we're switching on the address of the jump table. We've got cases of individual, like, I guess this binary had symbols in it, so it actually solved a symbol in the original binary. So we convert that to SSA form. We start optimizing things, eliminating dead stores that aren't necessary. So you can see these are just got addresses for position independent. Gets rid of those, eliminates a bunch of copies. So now we're folding expressions. So we're folding all the expressions that made up this big switch statement calculation. And we got this big switch statement with a huge calculation for what kind of switch statement we're dealing with. So now we get it's simple, and we can just straight up simplify that expression. And here's where the magic happens. So we have simplify switch value. What this is going to do is reverse optimize. So it's taking this value and undereferencing this pointer here. It sees the destination of where it's going and figures out what values those came from. So
undereference has got to be my favorite new term.
So it's going to undereference that pointer, so you get these values went to these locations. Then now we just have like an addition, so it can just subtract those out. And we have a shift, so it can just do the inverse shift. And now we have something that looks exactly like what you would see in C code.
That's awesome. I love it. That switch statements was a very difficult thing when I was trying to write a decompiler as well. Like trying to do that stuff where you go backwards from what the actual switch statement is was very complicated.
One thing that I want to mention is that all of this analysis that Rusty's showing that occurs from medium level IL to high level IL to get the final decompiled result, essentially. A lot of people were like really concerned, like what's going to be the performance hit to Binary Ninja when you've got a high level IL. And it turns out it's a negative performance hit because we actually did some optimizations between the last table and this table. And so even though you have high level IL turned on, you're getting full decompilation for everything. It's actually running faster on average than the last table
like
release.
Something like 20% faster.
And as soon as we're off of this call and get everything ready and working, and we verified there's no major blockers or anything, we'll be pushing a new optimization that actually changes the way it queues up analyze functions. And if you have a box with a bunch of cores on it, so you have an 8-core box or more, it will actually more efficiently parallelize, and you get a very large boost on a lot of binaries. Like sometimes it will be half the time of what it is now.
Oh, amazing. That's excellent.
With that patch, and if you give yourself a swap file, because it's a big binary, I've taken a debug Chrome binary, 1.5 gigabytes, and analyzed it in 30 minutes.
How much memory did it use? Because everybody is always
Yeah.
like, "Oh,
About a
my
few
binary
bytes.
my binary ninja's using 2 gigs of memory."
He had to buy more.
You just need a big swap file.
Oh.
Yeah, memory is also something that we do want
You
to.
don't actually need a lot of RAM. You just need to set up a swap file.
So the real trick is going to be what we want to do is get our memory utilizations down so that we can actually just keep all the IL references around and have all the IL. Because part of the reason that we use a lot of memory is because we're just computing all the ILs. We don't keep them all the whole time.
Well,
Which means
we do keep some amount of them. We keep essentially like 1,000 functions like cached of like a most recently used cache. But the plan is like we would love to be able to not have to have that cache if we don't need to, and even decrease the memory overhead to the point where like it doesn't matter. Yeah, we keep everything in memory. We can stream it to disk if you want to like decrease what your maximum, whatever you set as your maximum amount. But yeah.
Awesome. Well, do you want to show any more high level IL stuff, or we got about 20 minutes left? Do y'all want to go to questions or keep playing
I think
with Ninja?
we should go to Tim's stuff.
Let's do Tim's first, and then we'll do questions.
Okay, let's do. Take
it
away.
So Tim is going to show the newest stuff that's still on the pipeline. That is, kind of bleeding edge stuff that, I, in my humble opinion, is like the most cutting edge thing to come to reverse engineering since the advent of the Decompiler.
Bold claim, Peter. Bold claim.
It's a bold claim, but I stand by it. And
kind of problem.
Yeah, if you fail us,
no pressure.
Yeah, no, but the thing is, like, what has happened since like people have been using decompilers lately? Like, everyone's just doing incremental improvements on decompilers, and we think there's a lot more that can be done to help people understand what programs are doing. And that's kind of what Tim has been trying to do fundamentally. So yeah, I'll let Tim speak now.
Sure. Yeah, so one thing that is particularly interesting to me is the application of machine learning to the reverse engineering process. And so that's a very deep vein of research and lots of potential ideas and whatnot. And so in that endeavor, you actually come across many different things that you say, man, I could really apply it here, and we could really get some major benefits out of that. And so anyway, so that's kind of my interest. And so what I'm going to show you is kind of the result of some of those efforts. So I'm going to, and also there's probably a non-zero chance that a crash occurs during this demo, but at any rate.
There's so many crashes that happen on my stream that it would be a welcome change for it to happen not from me.
To someone else, yeah.
Yeah, so take it away. I'm happy to see it crash.
So here's a relatively a modest binary, but there's obviously quite a few functions involved here, and this is without symbols. So this is what you would typically see. This is a C++ application. I'm just kind of scrolling through that list of subroutines to kind of give you a picture of what this binary looks like presently. So we have the high level IL going on and so forth, and that's great. But while I open this up, in the background, I have a little agent that's operating and doing some things for me. And so in this little list down here at the bottom, it's gone. One of the biggest things that it has done is it's done this thing called factor modules. It's named some components and so on and so forth, and it's working on some stuff along the way here. And I'll actually walk
explain
through
what the components What
Yeah,
component?
I'm going to actually walk through, each of those steps as it's chugging away there. But the biggest thing is, and sometimes it's easy to forget for me as somebody who's been working on this for a while, what the first key steps were, and how important they are for all the subsequent steps. So the very initial step that seems to have enabled a lot of the other things that we're doing is to factor a program into a collection of components. Seems like sort of a natural thing to do, but it's also very important from an analysis standpoint, because it gives you smaller chunks of the binary to analyze. And it enables lots of interesting things like interprocedural analyses. It also allows you to condition your machine learning and your training based off of sort of this local neighborhood, which is a component or a group of functions. And so what does that look like? Well, it's pretty easy to present. And so what I'll do is I'll go over on the left-hand side of my screen here, and I'll click on the output of the componentization or the factorizing of this program. And so instead of getting a single long list of subroutines, what we're going to present here is a hierarchical list of subroutines. And so this first group, it was assigned the name deflate, and there's actually quite a few components underneath that. But and within those components are functions. Now I should say, if you remember from the symbols list here, there are no names on the subroutines, but when we go back to this hierarchical view, somehow there's already names. And so this is, again, one of those little areas where we're able to apply the machine learning. And so the names for the components are actually derived from evidence within the binary. So the name chunk factory, for example, was found in the binary. The various names for the functions that you see here were extracted from the binary. These are things like messages, assertions, log messages, etc.
And Tim, we got a question in chat that
Yeah,
it was
sure.
basically saying, so, is this recovering, the original source file or object file kind of delineations? Is that what you're doing? You're getting the chunks, the original kind of binaries that during the compilation?
Right. So, so that was actually one of the original motivations. We thought, well, gee, it would be very helpful to divide a binary up into the different compilation units, and that's almost correct. But the issue is that one is that the linker has the liberty to move things around, and two, programmers are not always good programmers. Right, and so they can shove a whole bunch of stuff into a single compilation unit, or they can, spread stuff across units that really should have been put together, etc. And so what's actually being recovered here are functions that are related to one another or interact with each other in sort of they're highly interdependent. And so that kind of gives you these clusters or communities of functions that we call components. Yeah, so kind of walking through this outline here, these functions have some sort of relationship to one another. Here we were only able to pull out one of the names, but there's structures. Oh, I didn't mention that. So we recover some structure stuff for the components as well, and that's enabled in part by the interprocedural analysis that's confined to the component itself, plus a little region outside of that. But at any rate, the point is being able to factor a binary gives you a lot of computational advantage. So there's just other things. So as you go through these things, you'll find that the names are sort of helpful for the components. The names on the functions that are put there automatically for you are helpful. The fact that it creates the structures there. is quite helpful. And yeah, so that's kind of the direction here. So there's some other stuff too, I suppose.
Yeah, Peter was mentioning yesterday when we were talking something about it taking user input and like updating things based on that. Is that something that's been implemented, or is that still in the future?
Right. So that's something that is in development. And what the idea is that, this view right here is just an interactive view. So you would basically be working sort of hand in hand, right, with the machine learning agent. So you can name things, you can change things, and then it would respond to those changes. Right. So
Can you show a structure? One of the questions from chat was to actually show one of the structures that was recovered.
one of the structures.
Mm-hmm.
This is a short one. I'll show another example of that. I don't know this binary particularly well, but I will show you this. So this name right here is actually incorrect. So it turns out that, well, the machine learning model that we have trained right now is only trained on a modest data set. Thousands and thousands of binaries, but still relatively modest, and still makes mistakes. So that gives an example of opportunities for the reverser to interact with the system and so forth. But yeah. So the other thing, well, let me switch to another binary because it shows some other examples that I think are going to be interesting.
So while you do that, I know people were asking like when this is going to be available and stuff, but this is going to be part of like integrated into Binary Ninja Cloud, correct?
Eventually,
I mean not like
Yeah,
tomorrow or anything. I mean, but
so
like
that's where we see is the first application of this is you need good data, right, to be able to do this stuff right. And so Binary Ninja Cloud is kind of the logical first step in this, because it lets us refine our model. But yeah, eventually we want to roll it into all the products in some form or fashion.
Yeah, that's what I was thinking was like putting it in Binary Ninja Cloud would give you a huge data set of people
That's
uploading
part
binaries,
of the purpose
putting
of
names
cloud.
in.
Yeah, that's exactly part of the point of cloud, is specifically for applications like this. That's exactly why it exists.
So yeah, Negasora, get on that. All right.
Yeah. All right.
So
Negasora, who's helping moderate chat for us, is also our
so
cloud
we've only got a few more minutes because I'm pretty sure my wife has a meeting in like 10 minutes, so she'll need the room. So why don't we do some questions real quick?
Sure.
And the main question.
Screen up, and he can keep doing his. Tim, keep doing showing stuff off.
Keep doing stuff like that. So I think one of the biggest questions is like we've kind of touched on it a little bit, but what does the decompiler do differently than other tools right now?
I think Rusty's the best person to answer that one.
I didn't catch that.
What does the decompiler do differently?
Yeah.
What does Decompiler do differently than other tools?
I mean, it is pretty much. I think one of the biggest differences is the way it has the dual representation, the basic block and instruction plus AST for plugins to be able to manipulate it easier. And also the other difference is that we have an SSA form of it, which is not typical.
And I think, Josh, you even mentioned earlier, we were talking about how you could just immediately jump in and use it. Anybody who's been working with any of our ILs, that whole like the stack of ILs means that we have a whole audience of people that can already immediately manipulate it and use it. One thing that we don't have on an exact timeline for, but is still coming, is like the analysis pass thing too, where you can change the way that the different analysis passes work. And so when that's done too, same kind of thing. The fact that it's based on this like multi-staged process, and if you can make a change here and then impact the kind of results there, you already can kind of see that with like an architecture, right? Like when you write like a plugin to do lifted IL, you can change the way you produce your stuff, and you get change to your decompiler output way over here. But you can see where it happens. So like I think that visibility and like the API access throughout all that stuff is probably the biggest difference in terms of how high level IL works. Oh, we lost you, Tim. Are you done?
No, I think he just stopped sharing.
Oh, okay.
Let's see. What's something new on the roadmap that is unique?
Like that stuff
Yes,
that we just
that.
showed.
Analysis passes is something that I'm really looking forward to.
Yeah.
Yeah.
That
Some
will
other tools
hopefully
have
be a
that.
lot more robust than people are maybe thinking of it will be. We're expecting to be more like, hopefully more like LLVM in that, where you can plug into individual stages and hook things and modify things in very small steps.
Yeah. So.
Oh, and the display stuff too. We talked about a lot, Rusty. Right? Like right now, you sort of get what the decompiler produces, but at some point, we'd like to have the user be able to say like, change this less than 10 to less than or equal to 9, right? Or like there's certain like display level filters to clean up decompilation that don't change the accuracy of it, just make it more readable. Like there's some other plans in the future for
people
high
have
level output.
different preferences, like, oh, like
Or
let's
even just
drag
context
this variable definition into a while loop, and then it's like, oh, now it's a for loop that's constructed, and stuff like that. Or right click on this condition and say invert conditional and reflow the entire conditional, so it it's laid out in the way that they prefer it to be laid out in.
Also, options for how you want to see it. A lot of people might want some blank lines in certain places because they're looking at different regions of the same function and they want to split it out a little bit, as an example.
So Computerality asked, is the decompiler info saved in the DB or regenerated?
That is regenerated. That is not saved in a database. But all the information necessary to construct the same decompilation is saved.
And the
Yes.
decompilation is not the slowest part of the analysis,
Right.
too, right? Like you've already got
medium level ILSSA is by far the most expensive thing that we do, and that's already.
Yeah, we've been saying for a long time that medium level IL was most of the way to a decompiler, and the performance numbers show it's true.
Yeah. Well, we've got to wrap it up in the next couple of minutes. Are there any
a question earlier about the dwarf stuff? So sorry,
Yeah.
I didn't mean to talk over you. Just wanted to say that in order to drive the machine learning, one of the things that we needed to do was to be able to have a large set of annotated binaries. And so in order to make that happen, we have a dwarf importer, which will take all the dwarf debugging information and rename all of your variables, define all of your structures, etc. And so when you combine that with a high-level IL, it pretty much looks like source code. So at any rate, so the dwarf importing is something that is functioning now, and it's fairly robust as it has to be able to run across thousands and thousands of binaries, and that's going to feed our machine learning efforts. Yeah. So just to answer that question on the dwarf stuff.
Yeah, we got to go. Josh's wife is going to kick him out of the room here in a second.
Did you see me nodding?
We got to have a minute to thank all of our developers that worked on Binary Ninja. Brian Pochik, he's a machine. He's been cranking away on bugs. He's probably the first one to hop in and fix a bug whenever one comes up. Obviously Tim is working on all kinds of new things that are really exciting. Ryan, he worked on our type libraries and is continuing to work on the type libraries. They're coming along. We're excited about getting those out soon. Josh Negasaur in the chat, he's been doing Binary Ninja Cloud, kicking ass on that. Who else? Andrew, he wrote our thumb lifter, did all the arm thumb stuff. He's been doing the debugger stuff, which has been really cool.
Hey, we're
That's a new
gonna hang
feature.
around on the
But-
Slack. I'm gonna paste the Google
Yeah.
group that we're in. Josh has got to go, but everyone else can join
I'm
us and
sorry.
ask more questions. And the answers there. No, you're good. You're good.
Yeah.
So,
So,
hang around, everybody else, and we'll be here.
Yep. Thanks so much, guys. And I'll see you on the Slack, and hopefully I'll be able to start streaming soon. Peace out.